All right. Section 2.5, problem number 26, was a question that someone had asked. It's a limit as x approaches 0 just from the right of this mess here, 1 over the square root of x minus 1 over the square root of x squared plus x. All right, first thing we should always try on these limits is plug and chug, but of course, and we shouldn't be surprised at all, it usually doesn't work, and it doesn't here because right away you end up with a 1 over 0 minus another 1 over 0, and that is going to be problematic. So the function is not continuous at 0. So we're going to have to come up with another method. Okay, what I'm thinking probably occurred to people here, maybe we just weren't quite sure how to do it, is to take these two fractions being subtracted and to combine them into one. And in order to do that, we're going to need a common denominator. But the good news about this is we're actually maybe closer to a, oops, that was a mess. We're actually maybe closer to a common denominator than we might have thought just by looking at this. So let's try this again. There isn't a thing that you can do with 1 over the square root of x. That's not going to clean up at all. However, that second denominator's radicand, the x squared plus x, could get factored now just by pulling out an x. So to save a little bit of room, I'm going to switch to green here, guys, and just right there, I'm going to rewrite the x squared plus x as x times the quantity of x plus 1. And remember, there's a radical over that whole thing. So I'm going to take advantage of the property of radicals that says that a square root of a product can be split up into the product of two individual square roots. Let me show you what I mean by that. We're going to leave the numerator as just a 1 here. And the denominator, rather than writing it as the square root of x times x plus 1, we're going to split that into the square root of x multiplied by the square root of x plus 1. That concept right there is the fundamental idea about how we simplify radicals. If you had something like the square root of 40, you would break that 40 down into 4 times 10, split it into the square root of 4 times the square root of 10, and then simplify the square root of 4 to get 2 root 10. Anyway, so with that in mind, I think it's a little bit easier to see that the common denominator of these two fractions is going to be that denominator on the right, the square root of x times the square root of x plus 1. So the second denominator is already complete. We just need to make the first denominator match that by multiplying it by the square root of x plus 1 on the bottom, and then of course balance that out the same way up on the top. So where are we now? Let's see here. We are still at a limit as x is approaching 0 from the right of, and all right, to try to speed things up just a little bit here, guys, these two fractions now have the same denominator. So I'm going to go ahead and put them together here with their common denominator, which is the square root of x times the square root of x plus 1. Now in the numerator, the first term of that numerator is going to come from this product here, which is just the square root of x plus 1. And then minus, well, that term right there is the second part of our numerator. So now we've gone ahead and we've cleaned this thing up to some extent here, and we've got it now just as a square root of one fraction here on that side. Now, have we made progress is the real question. Well, if you tried plug and chug now, you're going to end up with the exact same issue that we had here before. Very quickly, I'm going to erase all of this as soon as I do it, but very quickly, you're going to get a square root of 1 here, which is 1, minus that 1. That's going to get you a 0 in the numerator, and this factor is going to get you a 0 in the denominator. So we're still at 0 over 0 when we try to directly evaluate. However, one thing that's now available to us that wasn't available before is the concept of multiplying by a conjugate on both the top and the bottom of this fraction. So we're going to take a look at our binomial numerator, the square root of x plus 1 minus 1, and we're going to try multiplying by the conjugate of that on both sides, top and bottom. So it's going to be the square root of x plus 1 plus 1 that we're going to multiply on both the top and the bottom of this fraction. Switch back to blue here and we'll close that off, and that's where we are right now. Okay, so with that in mind, I need a new page right here. Let's see where that gets us. So we are now going to be still at the limit as x approaches 0 from the right, but now in a big set of parentheses. Let's go back and see what that numerator is going to be. Okay, we're going to multiply our first terms now. The square root of x plus 1 times the square root of x plus 1, which is just going to get us x plus 1. Then it's the outer right here, and the inner products that are going to cancel each other out. Those are always opposites. So now our last product is -1 times +1, and that's going to give us a -1 up there on the top. Now the denominator is an absolute disaster right now. That is going to be the product of the square root of x times the square root of x plus 1, and then I'm going to leave it multiplied by this binomial factor here. So, that's a mess. So the square root of x times the square root of x plus 1 times, in parentheses, let me make sure I've got this right, square root of x plus 1 plus 1. Okay, that is no fun at all. And it looks like, and I don't know if it looks like we're making progress or not, I believe we actually are. The first thing to notice right here is that that numerator can be simplified. The +1 and the -1 just cancel out, and that makes our whole numerator just x. Now, what normally happens at a time like this, when things go according to plan, is that the problematic factor in the denominator, the part that would make the denominator equal 0, cancels out with something identical on the top. Now, if I look at my denominator, the only thing here that's going to equal 0, if we let x become 0, is this square root of x right here. That's going to equal, that was weird, let's try that again. That was going to equal 1, and that looks like it's going to equal 2 right there. So I'm okay with those two factors. It's that square root of x that I was hoping would cancel out, and I really was hoping to see a square root of x in the numerator to cancel that out. I was a little disappointed when we didn't see it, but the good news is, guys, that this x and that square root of x can still be simplified, and it'll still have the desired effect. So let's see where we're at. Limit as x approaches 0 from the right of, and here we go, we've got an x on the top and a square root of x, which is x to the 1/2 down on the bottom. Well, remember, guys, that anytime you're simplifying something like x to the 7th over x to the 5th, you're always going to take, your base is going to stay the same, and for your exponent, you take the numerator exponent minus the denominator exponent, and this just becomes x squared. Well, in this case, let me get rid of all of that. In this case, this is an x to the 1st power. This is an x to the 1/2 power. So we do the same thing I just talked about a moment ago. We take the numerator exponent minus the denominator, and 1 minus 1/2 gets us an x to the 1/2 on top, or just a square root of x. So that takes care of that and that, leaving us now with the square root of x plus 1 multiplied by the square root of x plus 1 down on the bottom. And as messy as this still is, we got rid of the problematic factor in the denominator, so I'm pretty sure that plug and chug is going to work here. So now I think it's time to actually evaluate this limit by putting a 0 in there. The numerator, quite obviously, is going to be the square root of 0, which is 0. But most importantly, down on the bottom, the square root of x plus 1 becomes the square root of 1, which is 1. And then in parentheses, we're going to multiply that by the square root of 1, which is 1, plus 1, which is going to get us a 2 down on the bottom. And I know sometimes this seems anticlimactic. We did all this work, but we did end up with a legitimate answer of 0 because the denominator was something other than 0. So that was a lot of work in that problem, but that gets us to the correct answer here of 0.